Hello everyone, this is 3dprintedmolds.com. Today we're going to be running some tests on a mold, specifically my trout worm mold in my 8 cavity quick change mold system. And we're going to be trying annealed PLA as the print material. That's what I'm injecting right now is the PLA. And then to the left, this is a polycarbonate mold um, of a lure that I was testing out for the first time, wanted to run trials on, and that is in the polycarbonate, which is my go-to. So my initial idea for this video was to test the annealed PLA versus polycarbonate being my go-to filament. So let's take a look at our first round of the injection of the trout worm here. Go ahead, unscrew those and peel them open. First impressions are these are looking pretty good. So these molds were annealed at 100 Celsius for a half hour, and they were also sanded smooth. I have a video, a YouTube short on how to do that sanding to clean up the mold so they'll come out really nice. And these ones, they came out pretty nice. Not 100% pass rate on these ones. After the annealing, it did. You could see there, it's got some flash. But after the annealing, it did warp the molds. So they took a considerable amount of sanding. Overall, not too bad. So let's go ahead and look at the polycarbonate mold. The lure I was trying in this canister mold is a wax worm that I was making at the request of somebody I've done some molds for in the past. And I was trying a 10 cavity wax worm mold, small panfish lure, and it didn't fill the mold cavity. I've got a little bit more design work to do on that cavity to get it to inject properly and get all the plastic where it's supposed to go. And you'll see that in a minute here. They didn't all fill the cavity. They did, however, all look really nice. Really not much flashing, maybe a little bit, but not much flashing. Could easily be picked off with your fingers. So at that point, I decided just to do the PLA. This pour in particular is going to be the fourth pour in a row with the PLA molds. It was rather uneventful up until this time. Only reason I recorded this one is because I added more plastisol to my cup because I was running low on it. I mixed up some more plastisol, which is why it's this nice fresh blue color now, and it hasn't degraded over the heat cycles of the plastisol. And then something else I wanted to show here was I'm spraying these molds with canola oil, and you should get a seam of canola oil to come out the mold after you sand it and do all that to get when the molds are flat. So I wanted to show that. Alright, so this is the fourth pour of this mold in a row consecutively, not giving the mold additional time to cool down because I wanted to really stress test the PLA. So we're going to go ahead and demold the fourth consecutive injection from this mold. Overall, still looking pretty good. Maybe a bit of flashing on some that we're going to end up just tossing aside to be remelted, but overall no real degradation in performance over the first 4 pours of the mold. It wasn't until the 6th pour when the molds really started to look bad and have a lot of flashing on them seen here. So on that 7th pour, which is this one that you're seeing here, I really cranked those bolts down to try to get as much clamp force as I could, and we're going to see the result of that coming out now. They're going to look a little bit better than the 6th pour. but still not as good as they were up until that 6 pour. I'll get them in frame here in a moment and you can really see what I'm talking about. Apologize for the not so great camera work. I was recording all this myself with just my phone, so just bear with me here while I take a look at these. And then get them in frame. As you can tell, some of them are still coming out pretty good, but a lot of them are coming out pretty bad. A lot of flashing that you don't really want to have to deal with, and some of them come out really bad, like that one, not great at all. So for the 8th pour, I really wanted to up the clamp force, and I grabbed a C clamp and really tightened down on this mold in an effort to try to see if I could just, within reason, continue to use it with better performance than what I got on that 7th pour, 6th and 7th pour. It was then where I noticed it was cracking near the bolts from how tight I was trying to tighten down the mold. So it was at this point where the mold was really on its last legs, but I was trying to see how far I could push it. As you can kind of see here, some of them still look okay, but we're really starting to get consistent flashing. Still better than that 6 pour when something really went wrong. I think that might have been when the mold cracked and I wasn't really getting a lot of clamp pressure through it. But as you can see, if once they come into frame a little better, we're still getting a handful that look okay, but a lot more flashing than up until that 6 mold when things really went downhill. Again, these were all consecutive pours without really giving additional time in between the demold and all that for the molds to cool down. And these molds do not reject heat as quickly as aluminum would. So I really wanted to make it to 10 pours in this mold just to have a nice round number. So this is the demolding of the 10th pour. You can see more of the same story. Most of them have flashing. Some of them still look okay, but a lot of them are going to have flashing at this point once it focuses here. Yeah, see there it's got some flashing on the ends there. Maybe some usable ones in the middle of that group of 4 there. But yeah, at this point I decided to call it quits, and I said this mold is done for. So what we're looking at here is all the usable baits. I picked through the 320 baits. I got 173 usable baits. That's going to be a 54% success rate with a annealed PLA mold. And it probably would have had better longevity if I was allowing it to cool down in between pours. But I really wanted to stress test it, like I said earlier. So. And another thing was I was rejecting baits that were absolutely fishable. Some of them had some pretty nasty flashing like that one, but some of them I would fish this bait personally. But if I opened up a package and saw flashing like that, I would say what the heck's going on there. And that was kind of my pass fail, if you would, whether or not I'd be happy with the bait if I bought it in a retail store. So this is the string from the 4th one. As you can see, much better than the 6th pour here, which is when things really took a turn. It got a little bit better in the 7th, but the 6th pour is really where it died. And again, so that means I got 5 good pours out of the PLA mold, consecutive pours until it crapped out. So taking a closer look at the mold, you could see a crack near the bolt there. Near the bolt heads, underneath the bolt heads, the material had started to sink in. If I was using washers, I maybe could reduce that cracking and that sink there, and get better life out of it, possibly. But I don't use washers with the polycarbonate, and this was supposed to be a 1-to-1 to see if annealing brought it up to that performance level. It didn't. I would still say that the annealing probably helped with the PLA performance. I normally don't use PLA at all for this. I've tried some in the past. When I've tried it in the past, I've noticed warping and melting even anywhere from 2 to 3 pores in. Pores being injection. I've never done open pore. I've heard of people having better success with open pore, probably because there's not the pressure from the injector as well. That tends to be a little bit rougher on these molds. So for right now, at least in my mind, polycarbonate is still king. Um, Still king of these 3D printed FDM molds. And in a minute here, we're going to talk about the dollars and cents of it all, if you will. So I went ahead and threw some rough numbers in a spreadsheet here about how the PLA did. Ignore everything on the left. I was calculating how much the PLA was distorting in the annealing process, so I can see how large I had to print the canisters to account for that growth and shrinkage. But let's take a look at the numbers here. So a total of 10 overall pours, 173 out of 320. Good. That's going to be a 54% pass rate. Go ahead, do that math here. 173 divided by 320. Go ahead and multiply that by 100 to make that a percentage. Fix my math, and then 100, 54% pass rate. So not that great. And then I did go online and find a similar design to this trout worm, $1.29 for a 5-pack of these at a well-known online realtor of fishing gear. $1.29 for a 5-pack is gonna come out to just shy of 26 cents per worm, meaning that our PLA mold yielded us $44.63 worth of baits if you were to try to sell them at the market rate. Then I'm figuring $8 of material cost, 6 for the PLA, 2 for the actual plastisol that we use to inject the molds, 4 hours of labor time for all the annealing, the maintaining the 3D printers and sanding, and then the actual pouring of the baits comes out to about $9.15 an hour, which is above minimum wage, but still not all that great, all things considered. For some people, that might be worth it to go ahead, print these in PLA, anneal them, and do all that. Maybe let the molds cool down some more in between coolings to try to get some more life out of them. You could certainly do that. It would probably work out all right. But for me, I'm sticking to polycarbonate for the time being. I've got some ideas of how maybe I can get some different PLAs to try, see if I can get the performance of the PLA up. But for right now, polycarbonate's king, and I'm sticking to it. That's been 3dprintedmolds.com. Check out my website. Hope to see you there.